weatronic.
Now we start the workshop with some basic informations and to configure a function and to configure a model with our wizard. First of all, you all know weatronic, so channel thinking belongs to the past. We have no more channels. We are absolutely free in programming our new model, and in the middle is the function. And now, Stefan, let's start with our functions.
Yeah, so today we will start with the very basics of the programming of Bad60, but this can be extended to whatever you need. And the basic idea is to use functions like you see here on the screen. We have a function. This is just a name and it describes what you want to do. So it can be rudder, aileron, butterfly or crow brake. It can be retractable gear. It can be smoker, whatever. It's just a name given by you, what you want to do in your model. And the function gets an input. This is the control, and the control can be really hardware, which means it can be a stick or a switch or a pot or rotary encoder, but it also can be virtual switches or logical switches. It can be other functions, it can be function mixers, whatever you want to use. And then the function creates an output which controls the servos, and it can control more servos. There can be up to 10 servos per function, and one servo can be controlled also by more than one function. So for example, you have a wing, you want to use one flap, there is one servo and it is aileron function and flap function on the same time. But this we will see afterwards. It is independent. The throws are independent on each function. And what we will do now, we will take a look on a short example on our radio. And therefore we connected one of our Bad60s via Wi-Fi to our network here. And now we use an standard browser to connect on the Bad60.
Okay, we will start the other window. Okay, give us a second. There it is. And now we have the screen via Wi-Fi. This is our radio.
Yeah, this is the home screen right now of the Bad60 here on the table. And first of all, we will create a new model. So we go to add new model, and we want to choose a free model, which means all that is created in the model as a function needs to be done by myself. We will see later on what the motor plane and the glider will give us for functions, which is a little bit a different system, but on the very end the result is the same. But for the first basics we will start with a free model.
Okay. And what name do you like?
Let's call it example.
Okay.
Which is a good example for an example.
It should be.
And now the radio is assigning all the data according to the model we want to use. And now you see here in the model configuration, which is the first step, you see the model name, there is no image, there is no info text, and the resolution we keep on 1%, which means all adjustments we do are displayed in 1% steps. There is the possibility to reduce it to 0.5 or 0.1, but usually 1% is fine. And the next step we do, unfortunately, the browser remembers that we were German first. And yeah, the second step we do is the receiver configuration. So we go here and we choose a receiver. And receiver is here on the table micro 12. You can see it here. And therefore we will choose the micro 12.
There it is.
And after choosing the micro 12, we will bring the radio to the binding mode.
You see, you can start the binding, and after that, you can easily go to your receiver.
Then we use the battery pack here and power on the receiver. And after powering on, we have 30 seconds time to plug the binding jumper on the SCU port. And you see now.
Yep, and it's,
First it was slowly flashing, and then it got continuous green, and we got the successful binding.
Yep.
Now you see here, battery life value 5.3, warning is 6.8, therefore I get continuous warning right here, and I adjust it. So 4.5 is okay for 4 cells nickel battery. And that's it with the receiver configuration. And now we will connect servos to our receiver. Therefore we go to the servo configuration. And we have here 2 servos, one with a red arm and one with a green arm. And first we will connect the one with the green arm here to servo plug number 1, which is here. And therefore on the servo configuration side we will also name it. So this will be the green one.
The green? Okay.
And here you can adjust the center position. So it will be a little bit more up or down, whatever is necessary. And also you can adjust the limit, and also there is this test function button here, and you can press it, and then the servo will slowly move towards the limit, and you can adjust it. So for example like this. So you have center position, lower limit, upper limit, whatever is necessary. And on the second servo plug we will connect the one with the red arm. So here we go, and therefore we name the second servo red.
And done.
So right now we just have those 2 servos, so we're fine with red and green. And now the receiver is asking if I want to set the servo travel according to the limits, and I confirm this. Now I go to the function side. This is where we started our conversation, and like I said, the function is completely depending on your wishes, so you have to add a new one. It's just named function 1. Then you assign a control. This can be, for example, the right stick up and down. So you see here the control assignment, and when I move the stick, it gets selected. And then this control is the input for my function. I can also have a look on the setup. Here you can adjust all the fine-tuning stuff for your function. So for example, you want to use different rates or expo, differential, Also, you can here adjust the curve according to your wishes up to 33 points, whatever you want to do. And now you assign to this function 1 your servos, and here on function 1 we want to use servo 1. So we press here for waiting a moment.
Yeah, could be because of our test before.
So here we go. We want to add servo 1, the green one. And now we see when we move the stick, the green servo moves, and also with the blue background, we see which side the servo is moving right now, and where we also can adjust the travel. And we do the same for the second one. We create a new function. It's function 2. We assign a stick. Now we choose the left one for left-right direction, and again we choose a servo. So we press here for the plus, choose servo number 2, the red one, and now we see the red one is moving according to the stick. And now we start to think a little bit, and we will call this function here elevator. Okay. And we will call the second function rudder, which is representing a small plane just controlled by elevator, which is on the green servo, and by rudder, which is on the red one. And now I want you to think a little bit about our function system and remember what I told you before about the independency of functions and that they can control more than one servos, and want you to share your ideas how you would make this elevator rudder function now to work like in V-tail. So both servos have to move for the elevator and both servos have to move for the rudder, but in different directions. So please share your ideas via chat, for example.
How to do this? Just give us your ideas.
Yeah, no ideas yet. This can't be. So many weatronic users. And the question
Perhaps they know the answer.
Yeah, okay. Here is one answer from Jean-Harry Svensson. I hope the name is pronounced correctly. Include servo 2 for elevator and servo 1 for rudder, which is absolute correct idea. So for this you don't need any mixers. You just go here, add servo 2, the red one, and now we're on function elevator and we will check this, and unfortunately one is moving the wrong direction, which is the green one, because when I pull elevator up it's going downwards, so I have to reverse the direction here, and now they're both moving upwards for elevator and downwards for elevator. And now I go to the rudder and also add servo 1 here. And what you see now, when I move the rudder stick, they're moving on different directions, which is correct according to rudder function. And like I told you before, the travel you have here for the servos are independent. So I was changing the direction for servo 1 on the elevator, but it's not affecting the direction of servo 1 for the rudder. And also the travel is independent. So when I go back to the elevator function and reduce the travel here to a very small amount, so you can see easily, like this. Now the travel is very, very small for the elevator, but on the rudder still there is the big travel. So this is the basic idea of the weatronic programming philosophy. We can create functions. They get a control input, like you see here, function, elevator and rudder, controlled by these two sticks, and they give their values as an input to the servos, and the travels you give them and the direction is completely independent. And yes, you can do all this in the field.
Yeah, sure.
And what we will do now, we will show how this function concept or programming philosophy works on a small plane. So you see in the background here we have a small glider here with 4 flaps and a retail, and we will show how our model wizard will guide you through. And yeah, there is one question from Elvio Garganijo. I hope it was okay. He asks if this is like a mixer. In fact, it is not like a mixer. It's more an addition. So, for example, the function elevator controls servo 1 and 2, like you see here on the servo assignment screen, by 12 and 16% and 8 and 19, while the rudder function puts different values on the servo. So when I pull up the elevator and the servo value changes, it can still be changed by the rudder, but it works mathematically like a simple addition. Yeah, there is one question of the travel curves. I can just shortly show them. So basically, there is a 33-point curve. You see here, which is now the very small values given, and you can add new points somewhere in between, wherever you need them, and also move them later on wherever you need, either by clicking with the mouse or plus minus. And when you now look to the servo, it will move according to the curve.
You can do this also directly by on
Yeah,
the touch screen on the radio.
it's all exactly the same like you see here on your computer screen.
Yeah.
It's the same screen on the radio, and instead of using the mouse, you use your finger on the display. So, but now coming back to our model wizard.
Put this beside. Jan Harry, once again, thank you. He wrote a very good article in Norway, Stefan. That was Jan Harry. I showed Stefan the article, but we only could guess what you wrote.
Yeah, and also it is exactly the same for the BAT64. So now we will start with creating a new model. Therefore we go to the model management again, add a new model, and we want to add a glider. There's a warning. RF connection to your receiver is still enabled, which is correct because I just put it away from the table, but didn't disconnect the battery.
Yeah.
So the radio warns you when you forget to unpower your model. And as I just unpowered it, I can say ignore.
Okay.
And
what
now
name?
we call this model Caldera S.
Okay.
Oh, almost.
Okay.
Yeah, still almost.
No. Okay. Better?
Now we're fine.
Okay.
So here we go. Oh, this model name already exists.
Okay.
Yeah, then we have to change it.
Okay. What do you like?
Call it S2.
S2.
Yeah, we need to be. Yeah, like you want.
Okay, like this.
So now
Shall I move the glider?
No, we will start
okay?
with the retail, so it's okay.
Okay.
Yeah, now we're going according to the our model wizard, and it asks you step by step how your model looks like, what kind of model it is, what servos are inside, and according to what you tell the radio your model looks like, it will create for you the functions and assign the servos. So what we did right before with this little example of the two servos will be now done for all the complex stuff you need. And therefore we will start here. We have the model name, we can add an image, we can make an info text here. We just will make a little text here, programming example, for example.
Programming example, for example. Okay.
Here we go. Again, we have the resolution, and now we come to the tail type, and we need to change this to the retail. Like you can see here, and we will go on and say on the wing there is 4 moving surfaces, and that's it for the model configuration. And now we choose the mode, so we fly mode 4 here.
Okay. No more comments?
No more comments.
Okay.
And we will choose the receiver. In this Caldera we have a Clever 6 receiver. And we start the binding again. And we go on that.
The second battery?
It's all prepared.
Stefan.
So, powering up the receiver, and after powering up, we connect the binding jumper, and like a professional weatronic user, I was using a little cable to get the SCU out of the fuselage.
Now it's connected. Yep.
So
Perfect.
it's connected. There should be battery life value.
Yeah, should be. No life value.
Wondering if I did everything right.
No.
So probably.
Okay. This is
Now
live.
it's in the binding mode.
This is live, so
Probably I connected the jumper to the wrong pin. Start the binding again. Here we go.
Okay. Perfect.
So here we go again with the warning threshold. We will reduce it. So now it's okay, and all the other values can stay like default. So you get a range warning when your listen quality index, so the number of decoded frames is below 30%, you get a back channel warning on 1%, failsafe timeout. We don't need any sum signal, and we will not use the servo pulse synchronization to put as less stress on our power supply. Yeah, the next step now already starts. There is a short question of the range warning, and we are sending 100 frames per second, which means every 10 milliseconds there is a new frame, and the percentage gives the number of frames received in 1 second. So if there is only 30% of the frames, 70% or 70 frames in 1 second got lost, and 30 frames got received and decoded properly.
And that's enough to control the model safely.
Yes, 30 frames is still every 30 milliseconds a frame, and you will not recognize this. But if the value drops below, then there usually is something wrong with the antenna configuration.
What do you think is the minimum?
The minimum to fly, I would say, is about 5.
Okay.
But when you're on 5, you're really have...
It's the absolute minimum.
Yeah, but when you're on 5, it's just like antenna is broken or something else.
So when you keep the 30% will be perfect.
Yeah, and usually during flights, even with big models, it should never drop below 50%.
But you have also the back channel, and back channel is the default value of 1%?
Yes, because it doesn't matter when the back channel drops, because this is just giving information from the plane.
Okay.
So, yeah, now we see here our model, like we configured it, the V-tail, the 4 flaps, and we will start with the left V-tail here. We will add the servo, it should be number 3.
Yeah, Stefan still knows the numbers.
We will start here and give a little name for remembering. It's the V left side, so just V left, good name.
Okay.
And now we will start adjusting the center position, which is almost correct, but now really fine. And now we go ahead with the limits. So we go here for the servo limit, press the test button and see how the flap is moving. And you can put the value according to your mechanical requirements or mechanical limits. And also you should put the value according to the aerodynamical requirements. So usually the producers of the models give certain values, like you need 5 millimeters for elevator and 7 millimeters for rudder, and you add them and then you just set the value according to what is necessary. And also doing this step with the limits will save your servos, your linkages and your flaps, because the radio will never exceed these values, which is a very big benefit when it comes to safety. And also it uses these values as a basis to calculate the servo travels. So when you do this step here with the center and the limits, while we go on for the other side, very carefully.
V right, is it okay?
Yep. So when you do this right is right now. And yeah, so when you do this very carefully and precise, later on you will have a very precise movement of your flaps. So the elevator will move synchronously, and It also will have the full travel just when you reach the mechanical end of the stick travel. So again, the center position, and then we go on with the limit. So upper side can be reduced a little bit, and then we go on with the downside. Not as much necessary. This looks good. And you go on with this for all the other surfaces. So we go ahead with the left side. Now
Left side, so which one is it? This one?
Yep. So Ralph is moving the plate a little bit so you can see better.
No, you see.
Meanwhile, he's disconnecting the batteries.
Okay, it happened.
So now we're online again. And we will start with a flap here.
Can you see it? Is this okay?
Yes, it's okay.
Okay.
We will add the servo 1.
Yeah, that's
here. Which is not correct. It is servo 6, so we just delete it again and add servo 6 on this side.
This one is?
We name it according to the position, inner left flap.
Inner left?
Inner left, yes.
Okay.
So,
sorry.
So here we go, and we adjust the center position. Like this, and again we go ahead with the limits. So we have a very big for downwards direction, which is okay like this, and we have a very small level for upwards direction, because we just need a little bit of aileron upwards and a little bit of flap upwards for speed position, and we go ahead here with servo 2, which is the outer left, and again we use the center and limit. Not so far. Like this is looking fine, and upwards direction is looking good like this. And now we go on with the right side.
Okay.
So Ralph is moving again. Be careful not to disconnect the battery. So here we go. Perfect.
Okay.
Yep. So here we have now servo 1, and put the center position accordingly, and again we use the limit, press the test function, which is moving the servo slowly towards the limit direction, so you can check whenever there is something wrong. You see very good here for the downwards direction. I press the test and it moves slowly, and when I recognize, oh, it may be blocking, I can press stop and it will instantly stop again. And now with the test it moves slowly downwards, probably will reduce a little bit like this. And also we need to give the name, which is the inner right side. And to finish it, we use here servo 5.
And you see the remaining servos?
Yes,
in the list.
Now we have no remaining servos here, because all servos are connected.
Because it's a clever 6.
So, and this is now the outer right servo, or the outer right flap. And again adjusting the center position. Wrong direction. like this, and checking for the limits. Okay, like this, and downwards direction, not so far. This is looking good. And now we finished all the servo configuration. So we told the radio where the servos are put, and a little bit more to the camera. Here we go. So it's good. Yeah.
Like this?
Yep. And now when you go one step further, you could assign the remaining servos, which there are none because we just have 6 on our receiver, but if you have a bigger receiver, you can use here, for example, tow release or landing gear, and you just do the same like we did on the graphics. You give a name when you like, you can adjust the center, you adjust the limits, and now the radio created all the functions for your model, and you just have to go through the list and check if everything is moving right direction. So we will start here on the very top with the rudder. So we move the rudder stick and see, okay, left side is left side and right side is right side. Everything is fine so far. Now we go on with the elevator. Go to the servo assignment and see, okay, I go elevator up. The right surface is moving correctly, but the left is wrong. So I go here to the left servo, press the reverse button, and it reverses only servo left for the elevator. So the rudder is still working like usual, and elevator is working fine now. And now I do the same stuff with all my other functions. So I go here for aileron, servo 2, 6, 1 and 5. I go there.
You cannot see so good the outer,
Full deflection
the
of
outer ones.
elevator, no, not elevator, of aileron. And this is full left, and I see, okay, all the servos moving wrong direction, so I have to reverse all of them. And now all servos are moving right direction for my ailerons, but the flaps are moving way much too far. So here, the inner right needs to be reduced on the travel. I just go here and reduce it, like this, and now it's correct. And for aileron right, it's the same. Here, inner left needs to be reduced. Here we go, and now aileron is working fine. Then we check the butterfly. Again, it's using servo 1, 2, 5 and 6, but it's using them on different directions. So what I see right now, when I use my butterfly, the outer left is moving wrong direction, so I
cannot
reverse
see it
it.
in the camera.
The inner left is correct, the inner right is wrong direction, so reverse it again, and the outer right is right direction. So now butterfly is working fine. And on the last step, I will make a little flap function, which is already created by the wizard. Here I go and use a control. I want to use the left potentiometer for this. And now I see the flaps moving. Again, I go to the servo configuration, go for flap downwards direction, and check if everything is right. So I see, okay, inner right is correct, outer left is wrong direction, outer right is right direction, and inner left is wrong direction. So now the direction is according to what I want, and now I go ahead with the travel. So I reduce the inner left here because I just want to have a little bit of flap down. I do the same with the inner right and reduce it, or reduce a little bit more so it is symmetrical. And also the outer left needs to be reduced a little bit. So here we are fine, and now you see the flaps moving downwards exactly like I wanted, just a little bit of movement. Upwards direction needs to be a little bit reduced on the outer right, and the rest seems to be fine. So we have a little bit of movement on the flaps finally. We have normal movement on the aileron, and we have big movement on the inner ones for the butterfly, and moving upwards a little bit for the outer ones. We have correct elevator and rudder function, and so the basic setup of the model is done. And what you see here, extremely good, is the independency of the functions. So aileron, flap and butterfly are three independent functions using the same servos, but again with independent travels and directions.
Great. Are there any questions? When you make these adjustments, can you use the arrow keys to move more?
Yes, there is one question from Lance Campbell. When you go here for the adjustment, for example, here to travel, there are many ways of adjusting it. So I just can roughly click with the mouse,
or with your finger,
or on the tap on the screen, yeah, with the finger. You can use the plus minus buttons here, or there is one or many rotary encoders to be selected. So you also can turn this little encoder here and change the value.
So you can adjust only one to do this, or you can use all of them.
And if you already know the value and you don't want to tap around, you can go here for a numpad, use whatever you want, 93% or 17 or 12, whatever, and also you can restore the value with the recycle button and save it. So, are there any further questions on the basic setup of the model, how to create functions, how to use them, how to assign the servos?
If you go on, perhaps we can show this also. When you go on the next step in the wizard, you come to the overview. Yeah. Now you see the overview of the model settings, and then you finish the wizard. Yes. Okay, are there any other questions for this? Perhaps if you have any other questions, you can write this in the chat.
Or you also can ask directly. We can set you free for a microphone.
Yeah.
So we can have a little conversation, whatever you like.
Okay, otherwise, we will start next year with special workshops. So with further information about some functions that we have. So within the next weeks or months, we will explain all the features and the possibilities of our radio.
Yes.
Oh, on real life cars. Yes, we will continue. You can see we sent out today our new newsletter, and we publish also today our new firmware. So you see we have here 6.08, still with the startup warnings, teacher-student mode, and also other features like the update RX and an advanced control configuration. All this is in our new firmware, and we will start next year with other workshops. So within the next few weeks, you will get used to the radio, and you can use all functions as you know it until years. Okay, the question for the gyros.
No, first there was a question from Arno Sens. I hope the pronunciation is more or less correct. For the teacher-student function, you don't need another bad radio. There is a standard 3.5 millimeter socket, like on headphones or used on many other radios, and we just need a standard PPM signal. So when you go here and use the teacher mode, it will detect PPM signal, and when you go here for the settings, you can see the channels of your student radio, and as soon when there is coming a proper valid PPM signal, there also is the chance with a calibration button, which you cannot see right now, but there is one, so you can also calibrate the channels of the student, and so it is possible to work together also with other radios or with cheap ones, because for teacher-student you don't need to have an expensive radio.
So the gyro capability is the next question of Lance.
Yeah, the gyro capability will be in the next version, and we really just want to make the gyro functionality, so it should be ready by beginning of next year.
It's the highest priority right now. And to update the receivers, yes, you need not a special cable, you need a simple update cable. If you still have an update cable, you can use it.
Yes, the cable to update the receiver via the radio is exactly the same like you used with the Giga update function on the PC.
Yeah.
And then we have, do we already have a date for the flight
modes in English? No, not in English. In German, yes. But we will start at the beginning next year to plan also other workshops in English. And this will be also one of the next one, including the flight modes. Okay, perhaps the 6.08 is now the new version. And before we had the 6.06. But you can receive the software from our homepage. We have also an update manual, a short brief manual for updating your software. And we have in English the whole manual for the radio, still available on our homepage. So we are close to 8 o'clock.
Yes. So if there are no more questions so far, we would close this first workshop.
Yeah, thanks for
Thank
your
you very
attention.
much for your attention. If you have any further requests or special interests, you can always contact us via email or call us or right now in the chat. Also, when you have further interest on such online workshops,
Yeah.
we will continue this according to your wishes.
Okay. So thank you very much. Have a good Christmas time.
Yes. Have a
With your
happy
family.
new year and have an exciting working season in the workshop.
Yes. And yeah, we will go on next year with our workshops, and we look forward to see you again.
Weatronic.